mostly in the coastal areas for accuracy measurement of the geographical locations. Then SatNav satellite navigation system are used based on the Doppler measurements. So this is the example of the Lorentz, which is inbuilt in some high-tech tower. So the radio frequency are frequently sent to different locations. With the help of different machine, it receives all this frequency and get the exact location and direction. So earlier times, the Lorentz, Omega type of things are helpful for navigating in different areas. Like this is also one of the image of the Omega. So Loran has the highest accuracy in that time, which is 9 to 200 meter accuracy. Then Omega, which is low accuracy, but range is very high. That is two on 2000 meters range. So basically, some of the Doppler effects you also use for locating the difference uh, location of the uh, different machines. So theoretically, the expected Doppler frequency based on the satellite's motion related to the receiver, it is computed using satellite's coordinates and velocity and receiver's coordinate and velocity. So in the Doppler effects, we use satellite coordinates and velocity along with receivers like mobile or other GPS receivers are used as their coordinates and velocity. But in theoretically, there is a different result. But if the practical use, some shift is arises due to the clock drift. In the GPS satellites, there are some clocks are fitted. So if the clocks have some error, then its location also shifted. So Doppler effects is basically if based on the frequency. So if the frequency is very sorry, if the wavelength is very large, then frequency is very low. If the wavelength is very low, then frequency is very high. So based on the frequency and pitch. So if the frequency is very when some during some in the case of ambulance, when the ambulance come to us, then the wavelength of the siren is very high. So when the wavelength of the siren is very low and the pitch is very high. So when it is closer to the uh, man, then its pitch is very high and wavelength is very low. So wavelength and frequency difference are calculated. Based on this, the satellite location also used. The next slide is based on the Doppler's effect. So locations are calculated based on the Doppler's effect. In the first image, there is a high, there is a high sorry, there is a long wavelength and low frequency. So the particles wavelength and frequency when reached in the vehicle or is assigned to the receiver, so it is calculated from this part. Then the actual position of the systems are calculated. So in this area, that wavelength is very low and frequency is very high. In this cases, the wavelength is very low, frequency is very high. So frequency and wavelength are calculated at that time. The velocity of the signals also calculated. So after calculating this, the time difference also calculated. So time difference then resulted into the total distance covered. So So the global navigation satellite system, the worldwide position time determination system that includes one or more satellite constellation. Constellation means uh, some satellites, group of satellites, were used for a particular operations in a different orbits. So different constellations are there for different countries using for different satellites like GPS or other observation satellites. The most significant changes navigation technique is the advent of GNS, that is the Global Navigation Satellite System. It is started with the launch of US Department of Defense Global Positioning System in the year 1973. Early application of the GNSS were developed for the military and later it is used for the field survey and mapping and also used after that to civilian use. Now a lot of applications are there using the automobiles and different land survey. So, what is the function of the GSS? GNS employ a constellation of satellite which broadcast signals that are processed by GNSS receiver. So, these are normally just over the Earth's surface, but it can be in space as well. So, have been significant number of development in the ability of new satellite navigation systems like GPS in USA, Galileo for Russia, GLONASS Galileo for Europe and GLONASS for Russia, Video for China, IRNSS India, QZSS Japan. Some of them are globally coverage GPS system, some are in regional area. So there are three in this picture. There are three orbits are there for its constellations, and each orbit have 9 satellites. So in this type of system are found in different constellation of GPS, Galileo, and GLONASS. So there are nowadays seven constellation of satellite systems are there for different countries. So GPS, GLONASS, Vido, Galileo. These are all global globally available satellite system, and QZSS, which is operated by Japan, are INNS, Indian Regional Navigation Satellite System. These are available regionally within the country or buffer of the country, some buffer area of the country. So GPS is on. It is the first launch in 1978, and GLONASS, which is operated by Russia, it is launched in 1982. Vido, which is launched in 2000, and Galileo, which is launched in 2011. So GNSS system currently includes for the GPS there are 31 satellites. GPS satellites are there, which are used for navigation purpose. These 31 satellites are oriented in four different orbits. Then GLONASS, which is operated by Russia, it has 24 total global coverage satellites, that is GPS-based satellite. Then Galileo, which is operated by European Union, they have the 30 satellites. In Vido, China, they have the 35 satellites, and IRNSS, Indian Regional Navigation Satellite System, they have only 7 satellites. QZSS, which is operated by Japan, they have only 3 satellites regionally operated. Gogon, that is the full form of GPS aided geo augmented navigation system. That is the part of the IRNSS. So most of the objective question are asked, what is the full form of Gogon? What is the mm, full, what is the globally coverage GPS satellites are there? So this type of questions are there. And what is the full form of IRNSS? How many satellites are there for GPS or a QZSS or INSS? So you have to mm, go through it. So these are some previously asked short questions in exam. All GNSS satellite system consist of three major components. So there are three components in the GPS satellite systems for the operations. First is the space segment. In this segment, there are the GPS satellites are there, which are moving around the world with a distance of 20,000 kilometers above the Earth's surface. So these are the space segments. Then control segment. The control segments are based on the data uploading stations are there. The master control station for controlling the different GPS. Then base station to receive all these signals and correction. Then then user segments. The user segments in which all the users like GPS receiver, smart mobile, GPS present in the vehicle, or GPS based used in the aeroplanes. These are some user segments. So there are three segments. The space segment in the space segment consists of all these satellites, GNSS satellites, orbiting about 20,200 kilometers above the Earth's surface. So minimum the height of this GPS satellites are above 2,000, 20,000 kilometer. So each GNSS had its own constellation of the satellite arranged in orbit to provide desired coverage. So to coverage the globe, there are different uh, orbits are there. So for different GPS system, there are different orbits are there. Then control segment, the control segment comprises ground-based network of master control station, data uploading stations, and monitoring stations. In each GNS system, the master control station adjusts the satellite's orbit. Sometimes the orbits of the satellites may differ from their path. So to take into the original path, uh, some precision works are there, some clock errors are there. So to correct all these issues, the control segment is established, and then monitoring station usually installed over a broad geographical area. Different monitoring station for GPS system, for Galileo system, for IRNSS system are there in different locations to monitor the signals accuracy and the signals uh, consistency. To rely on this information to master control station. The master control station analyze the signal, then transmit orbit and time correction to the satellite for data uploading station. In the uploading station, the master control station analyze all these signals to transmit all these orbit and time information. Then the user segment, a lot of instruments are there to receive all this mm, satellite information. Equipment that process the received signal in GNSS system. Most of the GPS-based receiver are used uh, for tracking and information of the latitude, longitude, and height. So basically, in mm, some receivers, they receive multiple satellite system like GPS based system, then GLONASS information are also there, IRNSS also there. So multiple constellations informations are there to get the accurate data. We also have the GPS based information in the smartphone, but the accuracy is low as compared to other devices. Then brief history of the satellite navigation system. So previously The concept was developed in 1960. The Wheelbox, Sputnik, and Explorer. These are the Explorer-based satellites. So after that, the navigation-based satellite systems arises. The preliminary system, the transit operation in 1964, developed for submarines. So previously, the GPS-based information are very much useful in the navigation system for marine use. So TIMAS on satellites in 1967 and 69 used for fast onboard precise clock for a passive ranging and full-scale device, full-scale GPS-based development began in 1973. And this is also renamed as Napster in the US. Then four satellite vehicle launched in 1973. A GPS initial operation capability in 1993 December. So before civilian use, the GPS were used only for the military uses and defense purpose. So basically, the GPS for the survey work and GPS work, the forward bearing and backward bearing concepts are also used mm, to analyze the accuracy and the position of the locations. The forward bearing, that is a line in the direction of progress of survey, it is called forward bearing. So FB, that is this is the forward bearing. So alternative to this angle, it is called backward bearing. So for backward bearing and forward bearing are interrelated with the mathematical concept, that is backward bearing equal to forward bearing plus minus 180 degree. So if the backward bearing if the forward bearing is positive, then forward bearing is less than 180 degree. So this is the basis concept for satellite positioning. How can this is get the accurate information from different satellites? So traveler can use handheld GNSS devices, which includes GPS and GLONASS system. Then nowadays the precision farming also use the GPS systems. Application in the requirement of GSS further development in the develop very large scale. So basic principle of satellite navigation system are the satellite with known position transmit a regular time signals. So in the GPS system, there is a radio waves which are transmit from the space to the receiver. So the speed of the radio waves are equivalent to the speed of light. So we get the velocity of the radio wave, then time interval. So by applying all this calculation, we get the distance. So by getting the distance, we get the accurate position of the location. This is the principle where previously satellite based navigation system are not available. Then tower based navigation systems are used. So the value, there is a sensor is there, radio sensors. It transmit the radio waves when it reflected back to the original sensors. The time interval is calculated. Then the speed of the radio wave is already known, that is equivalent to the speed of the light. So distance is calculated. So if this going forward towards it, then its distance is closer to the sensor. So the distance is gradually decreases, and the position also changes. So likewise, the satellite also work in these principles. But in the satellite system, there is a atomic clock which is attached to the satellite, which is very high accuracy clock, and it is the accuracy of 1 nanosecond accuracy due to the precise location estimation. So the distance is like that, the delta t and the velocity of the light. Then the distance is calculated likewise. The time of the clock on the board. The time is very much important. If the time is not accurate, if 1 second delay or 1 second error is there, then the distance error is very high. That that's the issue. That's why the atomic clocks are attached to the GPS systems to get the high accurate informations. The navigation on this observed distance reference to the local clock referred to as pseudo range. So for the satellite information, for getting the accurate locations, there are minimum three satellite informations are there to get the locations. But if you want 3D informations with along with some height information, so you need to get minimum four satellite information to get the accurate location accuracy. So these are the some satellites which are mm, give that information to a receiver, GPS receivers, to get the accurate informations. Though in the satellite system, some messages are given to the receivers to get the location informations, uh, the date and time informations, and then satellite ephemeris data are there, which allow the receiver to calculate the satellite's positions. So ephemeris is a set of satellite orbit parameters like angles and other positions, which is used by the satellite systems to calculate the precise GNSS satellite positions and velocities. The ephemeris is used in the determination of navigation solutions, and it is updated periodically by satellite to maintain the accuracy of GNSS receiver. So various layers of informations are recorded by the GPS system. That is ephemeris data, then clock correction informations, then ionospheric informations. All of these are so recorded with the National Maritime Electronics Association. These are the information which are given in the black screen, which are get by the GPS receivers to calculate the accuracy of the locations. NMEI is a combined electrical and data specification for communication between maritime electronics such as echo sounder, sonars, anemometer, gyros compass, autopilot, GPS receiver, many other type of instrument. So the instruments accuracy and the precise location information are certified by the National Maritime Electronics Association, which is present in USA. And reception, the receivers need at least three satellite to obtain 2D positions and four satellite for 3D position. So sometimes some questions are asked. So how many satellite data are required for the navigation or position analysis? So the answer is four satellites are needed. If the more available, then additional observation can be used to improve the position. If six and seven satellites are there, then it is okay. But more than seven, eight satellites, information also decrease the accuracy of the positions. So GNSS signals are modulated by unique pseudo-random digital sequences or code. There is some codes are transmit to the receivers to get the information. Each satellite uses different pseudo-random codes, so it passes the different pseudo-random codes. Means these pseudo-random codes appears in the randomly and it repeats itself after a period of time. So it is periodically changes and same codes are received by the receivers. The receiver's machines know the pseudo-random code for each satellites. This allows receiver to correlate the GNSS signal to particular satellite. Though the code correction, the receiver is able to recover the signal and the information content. So in GPS system or in navigation satellite system, all the satellites have the atomic clock that keeps time with exceptional accuracy. These very high accurate atomic clocks are attached with the satellite. So every GNS certificate will include a clock. The time kept this clock is used to determine how long it takes for the satellite's signal to reach the receivers. More precisely, GNSS satellites broadcast pseudo-random code, which is contain information about the time and orbital path of the satellites. So the receiver then interprets this code so that it can calculate the difference between its own clock and time the signal was transmitted. So receiver have some clock time informations and GPS have their own atomic clock. So time difference were calculated and the velocity also known, then the distance is calculated. So this type of pseudo-random codes are sending from the navigational satellites. So suppose this type of code, some of the codes which are sent to the receiver, it is received after some time difference. This is the time difference which is given in the pink, sorry, in the orange color, the time difference. So this time difference is calculated with the multiplication of the velocity of the light. Then we calculate the distance. So if the time difference is very high, then the distance also increases. So if the time of the receiver is uh, some error, then the time difference increases and the accuracy of the location of the receiver's position is also decreases. It is very much. That's why there is a need of very much high accuracy time and atomic clock. So this is the pseudo-random codes in the satellite platform, and these are the satellite. This is the receiver's code, which is received after a time delay. And this is the span of the time. So these red lines are the receiver's satellite informations. So these are some eight visible minimum satellites are there to receive the informations. So this is the global coverage satellite system, which cover all the globe and with 4 to 6 orbits are there. For each satellite track, the receiver calculate how long the satellite signal took to reach it, which in turn determine the distance to the satellite. So these are the satellite which received by the receiver to get the accuracy of the information. And the ephemeris data is also one of the important factor for the GPS system, which is a set of parameters which describe the location of satellites with respect to time and which is transmitted from the satellite. So ephemeris data are the information getting from the satellite to get the locations and give the correct information. So basically, in the GNS system, we compare the triangulation and trilateration system. In trilateration, it is based on the distance rather than interaction of lines. So there are L1, L2, L3. There are three lines which is joined in A position. So the terrestrial survey indicate that in this image there should be probably a minimum of three control station. So in the survey part, we get the survey information with help of the triangulation method. So likewise, the GPS system also work in this manner, but they are this land survey are in the terrestrial form, but in GPS system it is from the space. In the both system, the measurement of distance to fix the positions. One of the difference between them is the distance and ranges in the GNSS system. It is very similar to what's done in the GNSS, and the GNSS satellite control point orbiting about 20,000 kilometers of the Earth's surface. There are four satellite system are useful for the getting the unknown information of XYZ like latitude, longitude, and uh, elevations. So for getting the information about precise locations, so we have to get the information of satellite system in a very sporadic way because it could not be in a unidirectional. If the satellite receive satellites are present in one direction and we get the information, then it will be a very erroneous information is there. So it will be received from different direction to get the higher accuracy. So it could not be in a linearly spread. Both the survey and triangulation survey begin with the control points. So these are some basic facts about the survey and the GNSS system. So these are the signals which are received by GPS receivers. Then if only one satellite signal was available to receiver, suppose one receiver get only one satellite informations, the best that the receiver could do use the signal time to determine its distance from that satellite. So for one receiver, it create a circle, then next receiver create a circle. So this intersection position is the position in which the receiver is present. So after getting the four circle, we get the point information, which is the position of the receiver. So we need there are four satellite information to get the location of the point. So likewise, if the two satellites are available, receiver can tell that its position is somewhere along a circle formed by the intersection of two spherical ranges. So when distance from three satellites are known, then receiver position must be one of the 2 points at the intersection of the three spherical ranges. So this GNSS receiver usually smart enough to choose the location nearest to the Earth's surface. This is the situation where the how the location is find out. If the one location is there, one GPS information is there. So these are the area uh, in which the receiver is found. So if the two satellites are there, then this is the area in which the location is found, possible location is found. In the three satellite information, this is the area which is found in the receivers. So after getting the fourth information, we get the point informations. In this, the information is getting the erroneous locations. So in the fourth satellite, the point information is get. So for the fourth, there are four satellites are the minimum to secure only one, absolutely technically. So if the question is asked most of the time, how many satellites are there for getting the information of precise locations, then the answer is four satellites, GPS satellites. So these are the equations which are used to get the position of the satellites. Pseudo ranges informations. P is the pseudo ranges. Then XYZ is the satellite vehicles positions. Then X1 XYZ is the user positions. X1 Y1 Z1 is the satellite vehicle positions. So this calculating this polynomial, we get the information. So basically, the GPS satellite clocks are essentially synchronized with the International Atomic Clock, and therefore it is also called as UTC, Coordinated Universal Time. That is one of the UTC. And GCF time drift ahead of UTC as the latter is not required very much. Some basic facts are there. So coordinated universal time, which is a system used for second define true angular rotation of the Earth measure if the rotation about is conventional terrestrial forward. However, UTC is adjusted only in the increment of 1 second. The time zone of UTC is that of Greenwich Mean Time. So GMT time is referenced with the help of the UTC. So this is one of the thing that GPS have the different signal structure. So each GPS transmit number of signals, that is comprises two carrier waves, that is L1 and L2 waves. Two codes, CA code and precision code, that is course acquisition code, and P code, that is precision code. And bandwidth allocated for the L1 is uh, 24 megahertz and L2 is 22 megahertz. So in the CA code, that is sorry, for the L1 it is 1575.42 megahertz frequency, and L2 it is 1227.60. So when the wavelength of the wave is very high, then the penetrating power of the radio wave is very high. So accuracy also very high. So in this case, the L1 is a very coarse very low accuracy codes, that is as compared to the L2. These are the techniques which are used for the course acquisition code and L1 carrier and P codes to get the signals, L2 signals and L1 signal. Then selective availability, which is deny high accuracy real-time position to potential enemies. Department of Defense reserve the right to deliberately degrade GPS information, CA code. CA code generally used for the defense purpose. Then accuracy, the degree of confirmation of that person with the true position. So what is the core acquisition code? It is the 1023-bit gold code. Originally intended as a simply acquisition code for P code as receivers. Modular with L1 only. For checking rate sequence length is not required. Provide the data for standard positioning service. So codes acquisition code is pseudo-random string of bit that is used primarily by commercial GNSS receiver to determine the range to the transmit GNSS satellites. The precise code, which is encrypted with the Y code, requires special chip to decode. The module both L1 and L2 frequencies are there, and the fundamental frequency which is used uh, in different frequencies are there. So the navigation message, in order to solve the user position, one must know what the satellite vehicle is. To know the satellite vehicle, the navigation messages are there. So satellite vehicle's own position information is transmitted in different 1500-bit data frame, pseudo Keplerian orbital elements, and different informations are there. The international telecom communication units which receive different information for different satellites. Then the almanac is a set of data which is downloaded from each satellite for the course of every 12.5 minutes to contain the orbital parameter approximation for all satellite and the GNSS to universal standard time conversion parameter. So almanac data is the information which downloaded by the satellites to get its information very high accurate due to the orbital shift or the time delay or the receiving and transmitting informations. All the informations are already uh, very small interval of time it is fitted with this information to get the high accuracy of the data. So different subframes are there to get the different receiving blocks are there. Block one, block two, and block three in the satellite system. And this is already also discussed. This is delta time, which is receiving from the satellite and generated code from the receiver. So calculating by this, we get the distance. And this is also the range difference received in the satellite phase, generated phase from the receiver. So these phases are calculated. What is the shift of the phases? By calculating the shift of the phases, we get the information of the accuracy of the satellite data. So various informations are determined like distance, shift of the distance, shift of the phase, shift of the frequency, and the pseudo random code. So all these are uh, calculated and give the accurate information in the name of latitude, longitude, and elevations. So most of the time, the satellite geometry mostly affect the quality of the signal and accuracy of the receiver. This is called as position dilution of precision. Reflect each satellite's positions. PDOP that can be used as the indicator of the quality of the receiver's triangulation positions. It is usually up to the GPS receiver to pick satellites, which provides the best position on trilateration. So, if the satellite elevations are in different angle in some are 45-degree angle or in 90-degree angle, then we get the information accurately. But if the all the four satellite information are nearly uh, some same angle, some if for satellite are in 30 degree, 31, 32, 34 degree angle, then it is get the wrong information about the locations. So DOP, that is the dilution of the precision. It is affect the quality of signal, which was discussed, and accuracy of receiver trilateration. DOP is the indicator to the geometrical strength of the satellite being tracked at the time of measurement. So, so this is the good GDOP because it covers in a different angle, large angle. In the right side, there the poor DOP, that is the dilution of precision, because we get the information from very small sphere of area. So we get the same type of information. So it get the more error. Quality of DOP very good if 1 to 3 and good for 4 5. Clear is 6. If the data is more than 7 or 6 satellites, then it can reflect the error in the receiver's information. Ideal satellite geometry to be in left side, there is the four satellite. It should be in this geometry to get the information. And pole satellite geometry is if the satellites are congregated in a small areas and we get the information from these satellites, then the accuracy of our position is very low, and it will be diffracted more than 50 to 100 meters in our position information. So geometrically, it should be ideal like this. So this is the clear description. That is a good satellite geometry. If these two satellites are far away from each other, then the position of the receiver is uh, very precise. But if the position of the two satellites are very nearer to each other, then their accuracy is uh, wider in this area. So in this, the accuracy is very less. So in the left image, the accuracy is nearer to 10 to 15 meter, but it is very high. So it is uh, advisable not to take this type of reading if the geometry is like this. So there are different globally coverage satellite informations are there. There are some metadata informations are there. For GPS, master control is in USA. For GLONASS systems, it is in Russia, and for Galileo in European Union. And surveillance is there are 11 stations in the GPS system. GLONASS, it has 7 surveillance system. Then Galileo has the 30 to 40 surveillance system. The satellites GPS is 31, and Lunas it is 19. So it is gradually increases by the time. So now I think it is 32 or 31 is uh, presently available. So now the increase of the satellite, some of the operational, and some extra satellites are for the backup use are fitted in the space. Then the orbital plane, and then inclination is in this area. Then altitude is nearly 2000 kilometers, and the repetition period is 1 day for GPS and 7 days for GLONASS, 10 days for Galileo. So the repetition of the GPS is very high. So the data information we can use for the GPS is very high. The probability of getting information about the GPS receiver signal is very high. So most of the time we use the GPS based information system uh, instead of the GLONASS and Galileo information system. Then these are some other satellite availability information that is not available. Anti-spoofing is a present for GPS. So if any wrong information are there, then they calculate automatically to get automatically corrected. Services and frequency band. So velocity is nearly same for all these satellites, and other things are nearly to the same. Some of the apps are there where apps and some of the handle GPS are there. So in this we can get the information like this. So if the black color is available, then satellite information is available and used, and some blue is available but not used. Satellite is unavailable. Then the red zone that is not available. So some of the application give the this type of picture. So which type of satellite information are used for our location information, and which are not used, they are give the details in the map format. So this is also one of the Android-based GPS test pro satellite-based GPS tracker. So in this, we can get the speed of the receiver, the bearing angle is there, and distance timing also there, which is fitted in this GPS. Then available satellites which are available, it is also given in this here, and the signal strength is also in uh, this bar diagram. So most of the time we get the GPS information system. This all these five satellite information are from GPS. Then it is also from GLONASS. This is one of the app where we get the satellite orientation, where the satellites are oriented, which number, what is the number of the satellite and the orientation of the satellites. Then one important thing is GPS error sources. So sometimes it is also asked for what type of errors are there in the GPS system. So there are various errors are there, like satellite vehicle error, satellite vehicle clock error, like atomic clock error. So it can be up to 1 meter error can be possible if the satellite vehicle clock is giving some error. Then satellite vehicle ephemeris data, if the ephemeris data have some error, then you also deflect some 1 meter accuracy error. Then selective availability, then if the availability information is not there, then 10 meter shift of the data is possible. Then tropospheric, when the radio signal travel from the different atmospheric layer, then the troposphere, one of the important factor, then can deflect some signal and delay some signals, and which can also get 1 meter shift in the accuracy. Then ionospheric layer. So most of the particles are there. So the maximum deflects can be possible in the ionosphere, which can deflect 10 meter. So pseudo range noise, if pseudo noise, then 1 meter. Then receive noise. If the receiver has some issue, then it is also 1 meter. Then multipath error. Multipath error, suppose it is uh, obstacle by some buildings or trees, then also give the error of 0.5 meter. Then RMS error, that is the root mean square error, it also uh, give the 15 meter error. And PDOP error, that is give the most error, that is 60 meter error. So in the DGPS format, features are calculated, and very less errors are found in the DGPS system, as this is a differential positioning system, and the GPS is directly receive the data and give the information. Okay.
थैंक यू सर. सर
These are
आप
about
स्लाइड शेयर
the.
कर देना सर एक.
हाँ हाँ, मैं शेयर करूँगा. Okay, then next we will discuss the different application of GPS in next class. So, is there any doubt or if any queries, then we can ask.
नो सर, जस्ट आप जस्ट शेयर योर स्लाइड.
Okay, I can share after completing all this class. Okay. Okay, thank you. Good night.
थैंक यू सर, थैंक यू, गुड नाइट. थैंक यू सर.
Thank you.